Hello again, and welcome to graphs of tangent and cotangent. So what we're going to talk about is how these are constructed and what some general characteristics are. So remember that tangent is sine divided by cosine by definition, right? So what we can do is we can actually overlay these graphs and come up with what tangent looks like. So please bear in mind that we have sine in the numerator divided by cosine. So what this is going to do, it's going to create some interesting things as we look at it. Okay, so I'm going to overlay these. So sine is in black there, and cosine is in green. And then what we're going to do is use that to help create a tangent graph. Okay, so the y values are going to be a little bit indistinct. You'll see why here in just a sec. But the x values are certainly going to occur with some regularity here. So with this scale. Okay. So the key thing we're looking for when we talk about what this graph looks like is that we're looking at the values of sine, particularly when the values of sine are equal to 0. So think like in a rational function. When the numerator is 0, the whole thing is equal to 0, as long as the denominator isn't equal to 0. So for instance, when we look at this, sine being in black, sine is equal to 0 at 2 pi at that's negative 2 pi. Negative pi 0, and in fact it's equal to 0 every pi radians. Let me just fill in these values here. So 2 pi, 3 pi over 2 over 2, pi over 2, 0 is obvious. So we're going to see an interesting periodicity to this graph that is going to be, whoops, that's not right. Well, of course, it's not going to cooperate, is it? An interesting periodicity. This is different from either sine or cosine, and we'll make sure to talk about that. See, but as you're looking at this, see if you can figure out what the period is of tangent, because it's not the same as a basic sine or cosine model. We know that the periods of both of these are 2 pi, of course, right? Right? So the other key thing that's happening is cosine x at some points is equal to 0. In fact, here, 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 and here, which means that there are asymptotes. So remember with rational function, when the denominator, in a rational function, when the denominator is equal to 0, we get a vertical asymptote. So what we get are vertical asymptotes to this graph every time cosine, there we go, cosine is equal to 0. So if you look at it, there is some obviously regularity. These are periodic graphs. And so what happens is we see this showing this same, well, this repeating pattern, but it turns out it's every pi. So here at 0, at pi, at 2 pi, we see the zeros, and we see the vertical asymptotes with that same, remember the difference between negative 2 pi over 2 and pi over 2 would be pi. Every pi radians, we see this repeat. So what I'm going to do is kind of focus just on one piece here and talk you through what this graph looks like here, because then it's going to repeat itself in these other cells, if you will. Okay? So what happens is we are looking at this being 0 here, right? And then what we've got is, because we have sine in the numerator, right? We have a small number, right, being divided by a large number, which is going to make it relatively small, but they're both positive. In fact, in this region, we're going to have a positive number. That would be the black, right, the sine, divided by another positive number. So we're going to get values in this region, okay? And over here, in this region, from 0 to pi over 2, we have negative values of sine divided by positive values of cosine, which means we're going to have negative values, okay? So part of the graph is going to be positive, part will be negative. That makes sense because it's got to cross through 0, right? It would only make sense that we're doing that. And it's also going to exhibit asymptotic behavior. So in general, what's going to happen is, so if we take a look like, let's say right here. At this point right here, which would appear to be when they're equal, right? This is going to be equal to right around, well, 1, okay? So looks like that we have the same value right here. So we have this value that's right around 1, okay? Now before that, and like I said, this is kind of an arbitrary y-axis scale. Before that, we've got these smaller values being divided by these larger values, so they're going to be relatively small. And they're going to get closer and closer to 0, where we get this really small value by, but it's bigger, almost 1, right? So what happens is we get this behavior like this, right? And then as we go here, past this point, we see large values being divided by smaller. So when you take a large value and divide it by a smaller value, like 2 divided by 1/2, that ends up being 4, right? So what we see is a rapid increase. And in fact, that increase becomes rather precipitous when we have something really close to 1 being divided by something really, really small. Think like something really close to 1, like 0.9, being divided by 0.001. That is going to be a very large number. As a matter of fact, it's going to exhibit this asymptotic behavior like we'd expect this way, right? Now, the mirror image happens, except it's negative, because like I was saying before, one is negative, the other's positive. So what we end up with is a graph that looks like this, okay? So then we see this repeating, that same characteristic, right, here. And this would just be half of it, right? The other half would be down here. So we see this is what a basic tangent model looks like, okay? Now, please note that this is repeating itself every pi radians, right? So that means that the period of a basic tangent model, so tangent x, is equal to pi radians. That'll come and become important when we start writing equations for this, all right? So it has to do with when sine is 0 and when cosine is 0, and that either corresponds to a root or a 0 or an asymptote, all right? By the way, there is a point of inflection right here, so we see it changing from concave down, so kind of like opening like this, to changing concave up right at this point, and this point, and this point. But it's the same graph being repeated. Okay, cosine is, or sorry, cotangent, my bad, is going to be very, very similar, except it's going to be slightly off, because the difference is, it's still, right, cosine over sine, so green over black. We're going to end up with the same kind of periodicity, repeats, right? The big difference is going to be what happens where. So just like with tangent, and I'm going to go a little bit faster on this one, here we're looking for zeros, that is, when is cosine equal to 0? Well, cosine's equal to 0, so that's the green graph right here. All right, because that'd be 0 divided by a number here. 0 divided by a number, by 1 as a matter, by -1, right? As a matter of fact, but 0 divided by -1. And here, and here. And similar to what we saw with tangent, and we're now, when you're looking when the denominator is equal to 0, and that would be dividing by 0, so it would be a vertical asymptote. So vertical asymptotes, and we see the same kind of pattern. Now, maybe we can move this over just to make it a little bit, there we go. So we see some, it's kind of an off pace, or if you will, shifted a little bit as compared to this for tangent, right? So the asymptotes are now where the zeros once were, which kind of makes sense because we've just taken the reciprocal of that, right? Flipped it. So now what we can do is take a look at what the values are doing. So let's take a look at this portion right here, and it's going to repeat just like tangent, except slightly differently. So my argument is going to be it's going to exhibit this asymptotic behavior very similar to tangent, but in a different way. Here to here, both cosine and sine are positive, so positive divided by positive is going to be positive. So we're going to see this graph coming down like this. And then when we get to here, the cosine is negative, divided by sine, which is positive, so we're going to get a negative answer. So what we see is that cotangent looks a lot like tangent, except slightly different. So instead of going up from left to right, this thing is going down from left to right. As a matter of fact, we'd say that this graph is decreasing continuously, whereas tangent, spooky, eh, is increasing continuously, right? Still has that asymptotic behavior, but they're like out of phase, where one has a 0, the other has an asymptote. Pretty spooky, eh? So that's basically what tangent and cotangent look like. So, characteristics. So there is a period, and both of those have a period of pi radians. Right? That's the basic period of both tangent and cotangent. Something to remember. Vertical shift. So if you're talking about vertical shift, you can still have the vertical shifts. You'll still be responsible for that. If you think about like the graph of tangent, it's got this point. This point right here where it's transitioning is normally at 0. So if you had a vertical shift, you'd be looking for where that point is. So when you're looking at the graph, let's say we know that's happening at like 2, that would mean it's been shifted up 2, right? Oops. And now we scroll down and see, oh, horizontal shift. So you can shift these things left or right in the same way that you can do sine and cosine graphs. And then vertical stretch. Now we're not going to see much with vertical stretch. It's harder, much harder to detect on these tangent and cotangent graphs, but it's going to change the steepness of the graph. They'll get steeper. So kind of like when we have a quadratic, so let's say that's x squared versus 2x squared, it gets steeper, right? It closes, right? This is going to exhibit the same sort of behavior for tangent and cotangent. But once again, it's harder to detect with tangent and cotangent. It's not like you have numbers you can read off with sine and cosine. But it does mean we still have a similar model. So to be honest with you, vertical stretch, which is A, we're not going to be seeing that much of. We will see B still being used to adjust the period. And by the way, this means that B, because the basic period is pi, is going to be equal to pi over the period, and which also means that the period is going to be equal to pi over B, depending on whether you have the equation and need to figure out the period, or you're trying to figure out from a graph what the equation is. And then this C is still the horizontal shift, and the D is still the vertical shift, though this is tracking where that central point goes. That is where it's changing from concave up and concave down. Okay? So we're not going to ask you too much related to tangent and cotangent. You are going to need to know the basic shapes, and at the very least how to adjust to the period, and possibly a vertical shift here and there. Okay? So that's all we've got for introing tangent and cotangent graphs.